Right. So yeah, now I have some stuff that I'm not going to spend too much time on. You don't really, although you don't need to know it that well. I do plan on at some point giving an advanced course, and it's basically work in progress here. Um, I mentioned already that you can have job arrays, which is essential. It's ideal for embarrassingly parallel jobs. What does embarrassingly parallel mean? It's basically very easily parallelizable. You have basically have a Python script and you have 10,000 input parameters you need to test. That is embarrassingly parallel. If they don't have any interconnect, it's just like you just need to try out a space of parameters. Um, you can start an array of very similar jobs from essentially a blueprint, and you could also think, well, I could also just use a for loop, a bash for loop to sbatch number of different jobs. Please don't do that. Use arrays for that, because if you use sbatch in a for loop and use a for loop to submit jobs, it will slow down our scheduler quite significantly because it's not made for that. Job arrays, on the other hand, are cool. How does this work? So this is an example where you don't use the jobs. This is something that you could do with could easily parallelize with an array, a Slurm array. So you have your job script, usual parameters, you load a module, and then you go through from 1 to 100, I don't know, whatever it might be. You can also go through files or something like that here, but in this case, just numbers from 1 to 100, and you run your program. That's it, with this as a parameter. This is one job which does 100 iterations sequentially. What would you do to parallelize to make it into a job array? You add this line. So this is new. Small, so lowercase a, 1 to 100. So you say I want an array with starting at 1 and going up to 100. Again, I load my Python module, and then I just say slurm array task ID, which is a bit of a weird variable. But this now spawns 100 jobs with that. For all the numbers from 1 to 100 will in each. So it will have 100 jobs, and in each of them, the numbers from 1 to 100 will be put into this one. So there will be one job where this is Python my program 1, then another job with Python my program 5, and so on and so on. Oh, you can tell that I did that in a hurry. Anyway, so this is a very simple example of how to use it. It seems a bit contrived, because who wants to do something with numbers from 1 to 100? Because who cares about that? I mean, that's a silly example. But before I have a more complex example, first of all, so this is just 1 to 100. This is the most simplest case, just a range of numbers. And what you have a few different options that you can use to denote job arrays. So this is the one you just saw. 0 to 5 is also an option. Like, it's a range from 0 to 5. Then you can give specific numbers. So I want to have an array consisting of task ID 1, 5, and 12. And you can combine. You can go from 1 to 5 in step size 2. So 0 to 4. I can use the percent sign to say, okay, I want to have in this case, from 0 to 11, but only 4 jobs at once. So this means how many are supposed to run at once. This one essentially just says run 0 to 11, but sequentially. Bit of a weird one, but sure, why not? And you can combine it all. So basically, 0 to 5 in step size of 2. And number 20, so 0, 2, 4, and 20, but only 2 at a time. And inside your job, you can inside your job script, you can control your job via environment variables. For example, slurm array task ID, which is what we used here. It's basically the task ID the job has. Then the count, which is in this example 100, so how many tasks there are in total. The max and the min, so in this case 1 and 100. And the step size, if you gave the step size. And this now is a bit more complicated example. This, again, we are on medium, and so, for example, you usually don't have 1 to 100 as a parameter in your script. This usually doesn't happen. What does happen that what you could have is a number of files, for example, named all end in the suffix inp, so input. So then you can just say, okay, I want to have all the files from that end in input. I count them first, so ls dash. I count how many there is. I will give that many array tasks, and this creates a bash array. And then you could say, okay, something like that. You do your big computation, whatever it is, and take. This is a way of using arrays like in bash, not Slurm job arrays, but just bash arrays, and say, okay, I want to have the ID or something like that. This, if you don't understand it right now, I can't really go into detail because we just have 15 minutes left. But this essentially means that all the files will be one by one go through with it. Go through not one by one, all at once, because it's a job array. They will all be simultaneously. The jobs will be started, and each job will have its own file. What else? There are job dependencies. So essentially, if you have, this is a good example. If you have a data pipeline in some way, or some kind of pipeline that you want to slice into smaller steps, because I mean the pipeline itself, if you run it completely, it takes 10 days, and you say, okay, I want to cut it into smaller chunks, and I have logical dependencies. So first I need to just do this step, then this step, then this step, and then you can, for that you can define dependencies with -d, and or -- dependency. You have a few options what to do. You can do something like after, and then the job ID. That means, so I need something to basically write here. So if this would be something like s or s batch -d, and then, okay, we have some. This is the job ID that we're waiting on, and no, after, and then the job ID we are waiting on. Something like that. We don't have that job ID, so I'm not going to send it. You can also have multiple job IDs here, however many you like. This is how you would now note, and then I don't know, job script.sh, some of you some script. You can also add a time. It means it will wait for a second. Like if you say, okay, wait 60 seconds after the first job has finished to start the next one, might be helpful at some point. After means that it starts after either the job has started, not after it's finished. After the job has started, or the jobs are cancelled. After OK means after the job is finished and successfully finished. So it didn't cancel or anything, or crashed or ran into out of memory or anything like that. Then after not OK is exactly the opposite. If it finished but it's terminated in some failed state, like out of memory or anything that isn't like I'm okay. And after any is essentially I don't care. So it's finished, but I don't really care if it was successful or not. Just go for it. You can use sbatch dash dash parsable, which is quite helpful when scripting dependencies. Why is that? Because I can show you. So usually if I have something like, I did have test as sh, right? So this is like you could now do something. Oh god damn it! It's sending me mails. I'm gonna stop that. If I want, so what would be ideal if I want to have dash. I want to have the dependency on after this one, but I don't want to. If I want to script it, I don't want to type it in every time. So I can do something like this. I can save the output into a variable, which in Slurm in Bash looks like this. ID is I just can be anything. My ID is so now echo my ID. Yeah, that ain't ideal. I can't use the whole string. What I can do is do as a parsable. Now echo my ID would only, so this means that it's only giving back the job ID. So you could now do something like sbatch -d after this, and I don't know, again test sh. This would mean, I mean, the job is very quick, so it's already done, but this means only after this job started that I submitted here will the next job start. Yeah, if dependencies, if you use dependencies and for some reason your dependency is not met, so example, if you have after OK but the job finishes unsuccessfully, you need to cancel them manually. It won't be automatically cancelled, and you can do a lot with dependencies. You should take a look into the man page or online help if you want to know more. Yeah, some miscellaneous options. If you want to have a simple command that you want to run using sbatch and not srun, use --wrap, which wraps it into a shell script. For example, if I want to have host name, I just want to. Now, this just wraps it into this command into a small script, and without you having to do a whole script. So this is all that happens. So this is the output of the hostname command. Yeah, that's something that is sometimes quite useful. I think I didn't. So let me. I think I didn't change again. So yeah, if you do something like this, then you send it up. So essentially, this hostname command has been wrapped inside a small script automatically by Slurm. And if you then take a look at this, you can see, okay, the hostname command has run successfully. And test only, right? Test only gives you an estimate on. It doesn't really run the command. It gives you an estimate on when it would run, so you can have an idea how long you have to wait. The open mode, basically, so it's for the output files. Usually, Slurm overrides an output file. If you have you could do something like sbatch -o out.txt. So this doesn't have any job ID or anything in that. So the first time I do this, it will create out dot as soon as it. Of course, now it's ready. Bullshit. out.txt. Sorry. Yes, this is what I expected. And if I do that again, question is now what happens? Does it override it or does it append it to the file? And we will see that soon. As you can see, it's a new, so this is the file has been overwritten by the new job ID. What I can do is add sbatch open mode equals append. So the truncate is the default. If I do this now, it should add it as soon as, yeah, now we can see there's the next output being appended to the file. Okay, now let me switch back. Export none. This basically don't export any of your user environment. For example, also not the modules you've currently loaded, which is good for reproducibility. So you don't have to, you can't set any. You have to do the whole setup in your job script itself, which makes it easily reproducible. That's quite nice. And you can also send signals. The next thing, you can send signals before the job ends. This is a way to essentially, this would mean send the signal 12 to the batch job 600 seconds before the job ends. And you could do something like trap the signal, that's something bash can do, and copy whatever is in your temp local directory to your scratch dir, and then start your job. So the job would run. You need to start it in the background and wait. I'm not going to go into detail here. And then once this signal comes, it will copy all the temporary data onto your scratch directory, so you don't lose your progress. If you, this is I can't explain that in more detail because this is just a beginner course, just that you have seen it. If you need that, let me know. I can explain it in more detail directly, but it's a bit much for this course. And yeah, I think I need to. It's actually quite fine, I think. Essentially, some general Slurm advice: please don't use sbatch and for loops. That's more for me because I don't want to debug the scheduler if all of you use sbatch and for loops. Reasonable time limits help a lot with. The more reasonable your time limits you set, the max wall time you set is, the shorter your jobs will wait. So that's good for you. If you use short test jobs, you can use the short QoS, just as an advice. And if you are unsure of anything, feel free to ask us. I'd rather explain something that is something to someone that asks nicely, but than to have like piece the cluster together because someone did something very stupid. So just feel free to ask at any time you want. And with that, the question is now obviously, how should I ask you after this course? And this is section 8, getting help. So the first thing you can take a look at is the man pages. They are quite extensive. Then there's the online help. Online in this case, not the website, but I mean on the cluster itself. For example, sbatch -help displays some the tourist information about how to use it. Then there's our documentation. There's also the user wiki, but keep in mind if you for the user wiki we can't really keep it up to date, so it might be outdated. So if you find something there and it doesn't work, that might happen. If you find something in our official documentation and it doesn't work, I mean, in both cases you can write us an email, but this should happen far less frequently. And then we have our mailing list, to which all of you have been subscribed since you're now using the cluster, where we have something like downtimes or new features and stuff like that we share over the HPC announced mailing list. If you want, so this is a user wiki, and anyone with a cluster account can add to the wiki, but feel free to tell us that you did that so we can have a look at it, and if there's some mistake in there that we don't want to be like that, we will tell you. And yeah, you can add a category scientific computing to the computations, to the contributions. Furthermore, we have a chat room, HPC users. Azad is now hopefully nice and links it in the chat. It's mainly for quick questions. We usually respond a bit faster than to tickets, but we might actually tell you to open a ticket if it's a more complex issue. That will, like, software installations often, like, we will do it when we find the time, but it's not necessarily a right now issue for us. So in that case, we might open a ticket. Tell you to open a ticket. And how do you open a ticket? You just write an email to hpc@gvdg.de. Please include your user ID, because it's easier for us. If you have any problems with specific jobs, include the job IDs and hopefully also the standard output and standard error. If you have a lot of failed jobs, if your whole job array failed, please at least give us 2 outputs that are representative, like one failed job and one job that succeeded or something like that. And if you don't mind us looking at your files, please also say that. You can also limit that to specific directories. We can log into your user account without knowing your password or your key or anything because we have root access, but we will not do that without you telling us that we are allowed to do that.